welcome to Gifted and Science and Technology Physics class. My name is NC Joshua. Today we'll be looking at capacitors, or capacitance, capacitors. So what are capacitors? Capacitors, a capacitor is a device used for storing electrical charges. A capacitor is a device used for storing electrical charges. What about a capacitor? It is represented as two parallel plates separated at a distance with a dielectric between them. So we have something like this, two parallel plates having a distance between them. In this distance, there is a dielectric material between this plate and this plate. So the electrical symbol for a capacitor is like this, and you must make sure that the two lines are equal. One must not be longer than the other, because the moment one becomes longer than the other, it's no more a capacitor, it's now a cell. This is a cell, but this is a capacitor. Take note of that. The lines must be equal. That's why it's called two equal parallel plates. So we have two parallel plates of equal size, but over here, this must not be equal. This is a cell, but this is a capacitor. So, what is capacitance? The ability for a capacitor to store charge is called capacitance of the capacitor. Look at it here. The ability for the capacitor to store charges is called the capacitance of a capacitor. And we use small letter C to represent that. Now, take note, capacitance is a scalar quantity. Take note of that. Capacitance is a scalar quantity, not a vector quantity. In short, as a matter of fact, most times when you hear anything that ends with stance, resistance, inductance, they are all scalar quantities. Now, mathematically, I have charge is proportional to potential difference. Charge is proportional to potential difference, that's voltage. Then I have charge is equal to, I brought in a constant called capacitance, then times V. So capacitance, which is small c, capacitance is equal to charge over voltage. The SI unit for capacitance is farad, and it can also be, if I don't want to use farad, this is charge, this is voltage. Charge is coulombs, so coulombs per volt. So farad can also be called coulombs per volt. What are the types of capacitors? We have different kinds of capacitors. We have, for instance, the ceramic capacitor. The dielectric material in a ceramic capacitor is a ceramic. So in a ceramic capacitor, you have a ceramic material in between the two parallel plates. What about in an electrolytic capacitor? An electrolyte is the dielectric material in an electrolytic capacitor. What about in a variable capacitor? In a variable capacitor, the dielectric material is air. Take note of that. In a variable capacitor, the dielectric material is air. What about in a or a film capacitor? In a paper or film capacitor, the dielectric material there is a paper. So we have uses of capacitors. What are the uses of capacitors? One, to store energy, that's to store electrical charges. Number two, to filter signal in electronic circuits. Number three, as to tune radios. This is the kind of capacitor found in radios. A variable capacitor is found in radios, and this kind of capacitor is that is adjustable. Take note, a variable capacitor is a capacitor that you can adjust. Then we have to smooth voltage in power supply. So all these are uses of capacitors, apart from just to store charge that we said from the beginning of the class. Now we'll be looking at how capacitors are connected in series and parallel, and how they are calculated. Now we'll be looking at connections of capacitors. Now we have the series connection and we have the parallel connection. This is a good example of something connected in series, and why this is a good example of something connected in parallel. Now, what about series? In series, the charge in this capacitor is equal to the charge in this capacitor, but the voltage in this capacitor is different from the voltage in this capacitor. So, for series, they have same charge but different voltage. Now, look at what I want to say now. If same charge, comma, it means that the charge in one is equal to the charge in two. That's what it means here. The charge in this capacitor is equal to the charge in this capacitor. But, but, but the voltage in one is not equal to the voltage in two. The voltage in one is not equal to the voltage in two. Therefore, the total voltage, the total voltage is equal to the voltage in one plus the voltage in two. Now take note of this. It means that in series, they have same charge but different voltage. The total charge, the total charge is equal to what you have in one and is equal to what you have in two. So I can still come here to tell you that this is equal total charge. But for the voltage, the total voltage is equal voltage in one plus voltage in two. So therefore, recall, recall. What do I want to recall? That V equals, I want to recall that Q equals CV. This formula was used when we said the ability for the capacitor to store charge is called capacitance of the capacitor. So Q equals CV. Therefore, what becomes V? V is equals Q over C. That's charge over capacitance. So therefore, put this into this. Let me give you this as equation 1. So now put V equals Q over C into equation 1. So what are we going to be having? We're going to be having now, remember this is V total. So in place of V total, we'll be having Q over C, that's this, is equal to, here again, we'll be having Q over C plus another Q over C. But mind you, this time, this will not be for 1, while this will be for 2. Now remember that the charge they have are all the same. So this will not be total, total, total. Why this will not be for C total. So I will now have, this can be equal to Q total over C total is equal C total, C total, Q total, charge total, charge total is common. So I have QT, open bracket, 1 over C1 plus 1 over C2. So now this takes up this, and I have 1 over C total is equals 1 over C1 plus 1 over C2. So this is how we express capacitors in series. What about for parallel? For parallel connection, what about for parallel connection? They have, now this one have the same charge, therefore this we have different charges but the same voltage. So for parallel, they have different charges, but they have same voltage. Different charges, same voltage. So if I have this circuit connected to a voltage, if I have connected to a voltage here, I can tell you that whatever is this voltage here is what will be here and is what will be here. Whatever is this voltage in this circuit is what will be here and what will be here. Why? Because in parallel they have same voltage. So I can tell you that V1 equals V2 equals V total when they are connected in parallel. So the total voltage in this circuit is equal to what I have in my C2 is equal to what I have in my C1. But in this case, the voltage is not the same. The voltage here plus the voltage here equals the total voltage in the circuit. But in this case, the voltage here equals the voltage here equals the total voltage in the circuit. Take note of that. But in this case, the charge here equals the charge here equals the total charge in the circuit. But for this case, the charge here is not equal to the charge here. So I cannot say that the charge in Q1 is not equal to the charge in 2. Therefore, the total charge is not equal to Q1 plus Q2. So I'll be using charge now to bring this out. How will I do that? Now remember, what is Q? Q, remember, let's do that here. I have Q equals CV. So if Q equals CV, put it into this formula. So I will now have, for this Q total, I have CV is equal to, here again, I have CV plus here again, I have CV. Now let's put it well. This is now your QT, so which is my charge total. Now tell me, what do they have in common? They have voltage in common. So this will not be my voltage total. This again is the same thing. This is the same thing. Why this is 1, this is 2. Why this is not my C total. So now I have C total, voltage total is equal to, what is common here? Voltage total, open bracket, C1 plus C2. This cancels out this. Then C total is equal to C1 plus C2. So in parallel, this is how we calculate for our total capacitance. But in series, this is how we calculate for our total capacitance. So now I'll be showing you a good example of some questions and how it can be solved. Thank you. Now let's look at example 1. Calculate the resultant. This word resultant can be total, can be equivalent. So calculate the resultant capacitance in the following. Look at example 1. This is a series connection. Whatever is coming in here will come in here. So the charge that is here will still be the charge that will be here. That's a series connection. So for series, number 1, for series we have 1 over C total is equals 1 over C1 plus 1 over C2. If it was more than 2, I would still say plus 1 over C3. But the questioner gave us 2. So let me do something here and assume it was 3. So I will have 1 over C total equals 1 over C1 plus 1 over C2 plus 1 over C3. So if there was an extension, that's how it would look like. Now, what's the next thing? What's the LCM? Is C1, C2. This takes of this. I have C2 plus C1 is equals 1 over C total. So what will now be my C total? My C total is now equals C1, C2 over C2 plus C1. This is what we call product. This is what we call product over sum. Is what we call product over sum. So if I am given a question like this, since it's just two capacitors, I will just say product over sum to get the resultant capacitance. So I will just say CT is equal, what's the product of these two? It's now 5 times 6 over, what's the sum of these two? 5 plus 6. So that will become 30 over 11. So my total capacitance will now be 2.727 microfarad. That's the way I can solve this. Now, what about if it's now up to 3? I will not do again. LCM will be C1, C2, C3. These are the products. Then this takes up this. I have C2, C3 plus this take of this, I have C1, C3, plus this takes of it, I have C1, C2 is equals 1 over C total. So what is now C total? C total is now C1, C2, C3 over C2, C3 plus C1, C3 plus C1, C2. This if it was involving three capacitors. This is what I will use to solve it. This is what I will use. But when it's involving two, this is what I used to solve it. So take note of that. That's how it is solved. Question number 2 is question B. The question B part of it, this is connected in parallel. And when it is connected in parallel, that's our B part. In parallel, our C total is equal to C1 plus C2. Our C total is equal to C1 plus C2. So what's our C1? 3. What's our C2? 6. So my C total here will be equal to 3 plus 6. So my C total will be 9 microfarad. That becomes the answer to my C total. Now let's now see our question number 3. Question number 3 is now a combination of series and parallel. So to solve question number 3, you have to ask yourself which of them is in parallel and which of them is in series. Now let me give you a little explanation to always know what is in parallel. Now just imagine I stretch this place. If I stretch this place, there is a high tendency that these two will clap each other or they will meet each other. So when you draw like a rope and these two can meet each other, it shows that they are in parallel. So this and this are in parallel. Another way you know is that a charge that is here, when it gets to this point, some will go up while some will come down, meaning these two places here, they are in parallel. So 5 and 7 are in parallel. To solve question number C, note that 5 microfarad and 7 microfarad are in parallel. So if they are in parallel, therefore, what is our total capacitance? Our total capacitance. Total capacitance in parallel is to just add, is to add up both of them. So my total will now be 5 plus 7, which equals 12 microfarad. Now I have solved the total for these two. So my new circuit would now be something like this: 6 microfarad and 12 microfarad. That will not be my new circuit. My new circuit will now be 6 microfarad. This one has been compressed already to now be 12 microfarad. So since I have these two already, what will now be my final answer? Now my final answer, which is now my C total, remember they are now in series. And to solve series, we said just do product over sum. Product over sum. So C total is now equals, what's the product? It's now 6 times 12 over 6 plus 12. So this will now become, C total is now becoming what class now? That becomes 6 times 12 is be 72 over 18. The answer is now 4 microfarad. So the total or the resultant capacitance in this circuit is 4 microfarad. How did I solve it? I first of all did these two as parallel, then now have a new circuit where these two is now combined to this one in series. That's what I now have here. So what is here is what will also be here in terms of charge. So this is now a series connection. So to solve series, we said product over sum, and that's how we got 4 microfarad. Thank you. Now let's look at another example. We are looking for the resultant capacitance in the circuit. Now, the challenge here is which of them is in series and which of them is in parallel. Now you look at this. The charge that is here, when it gets to this point, it splits into here and here. The charge here gets to this point, split into here and here. Hence, it means these two places, they are in parallel. Likewise, if I drag here, assume it to be a thread, I drag it, these two sides will definitely meet. So I can say 1 microfarad and 5 microfarad are in parallel. They're in parallel. Therefore, what's our total capacitance in parallel? In parallel is C1 plus C2. So C total will be 1 plus 5, which equals 6 microfarad. So these two plates have been compressed to 6 microfarad. What is now my new capacity, my new circuit? My new circuit will be something like this. This is my new circuit. So this will not be my new circuit. Now remember, this is 4, you see there. This is 4 again, you see there. Then this place has been stringed to 6. I've calculated it because these two are in parallel to give me that. Now, what is now this circuit? This is now a series connection because whatsoever enters here, enters here, enters here. So now 4, 6, and 4 are in series. So for total, to get the total of this, it will be 1 over total equals 1 over C1 plus 1 over C2 plus 1 over C3. Now, how do I do that? I have 1 over C total is equals, the LCM is C1, C2, C3. That's the LCM of this. Then I will now have here to be C2, C3 plus here will be C1, C3 plus y here will be C1, C2. So my C total will now be equal C1, C2, C3 over C2, C3 plus C1, C3 plus C1, C2. So my C total will now be equal to, what is any of them you take to be, let this be my C1, my C2, my C3. So it becomes 4 times 6 times 4 over, so now I will not pick, this is my C2, so it's now 6 times 4 plus, why this will not be my C, it becomes 4 times 4 plus 4 times 6. That becomes the expression. Take note, in case it's confusing, what you just need to do is to say 1 over C total is equals 1 over 4 plus 1 over 6 plus 1 over 4. That's what you just do in case this is confusing to you. Then LCM, you can say LCM is 4 times 6 times 4. So this cancel out this, I have 6 times 4, which is now 24, plus this cancels this, I have 4 times 4, which is 16, plus this cancels this, I have 6 times 4, which is 24. Everything is equal to 1 over C total. So what is now my 1 over C total equal to? 24 plus 24. So this will now be equal to 64 over 96. So now we now have C total equals 96 over 64, which equals 1.5 microfarad. So this is the way this is solved. We did this as parallel, compressing it to have a new circuit. Then we now solved every other thing as series. Now let's see example 3. Example 3 is a very crucial one, and I want you to understand it. Now, if you look at this circuit, 5 microfarad and 10 microfarad, they are in parallel. Now, I hope you know this, that 10 microfarad is equal to 10 times 10 raised to the power minus 6. Micro here means 10 raised to the power minus 6. So take note of this, but I just have to say it here because it's very important. Now, look at this. Both of them are in parallel, and we said in parallel they have the same voltage but different charges. The charge here is different from the charge here, but the voltage here equals the voltage here equals the total voltage. We said that in parallel, we said V1 equals V2 equals V total in parallel. So the total voltage is what is here, is what is here. So I can boldly say that the voltage here is 20 volts and the voltage here also is 20 volts. Take note of that. That's one good way to understand such question. So if I'm now asked to calculate for the charge in 5 and 10 microfarad, it means in 5 microfarad, therefore Q equals CV. Therefore, charge equals, what's my C? 5 times 10 raised to the power minus 6. That's the micro. Times, what's my V? My V is 20 volts. That's how to solve it. So what becomes my Q? Q for P will now be equal to, this is now 100 times 10 raised to the power minus 6, which equals 1 times 10 raised to the power minus 4 coulombs. That becomes the answer. What about what about in 10 microfarad? In 10 microfarad, I'll say Q equals CV. Now, this is for Q also. Now, what's this equal to now? What's our capacitance? 10 microfarad. That's 10 times 10 raised to the power minus 6. Then times, what's the voltage? 20. They have the same voltage, which is equal to the total voltage. So if you do this, this becomes 200 times 10 raised to the power minus 6, which equals 2 times 10 raised to the power minus 4. So this is 2 times 10 raised to the power minus 4 coulombs. So you see that the charge here and the charge here are different, but the voltage here and the voltage here equals the total voltage. Now let's look at another question as regards what we're trying to explain. It says determine the potential difference across the 5 microfarad capacitor. Now where is 5 microfarad? This is 5 microfarad. But remember, 5 microfarad and 10 microfarad are in series, but they are in parallel with 20 microfarad. That means that if this and this are in parallel, and this is our total voltage in the circuit. Now remember, if capacitors are in parallel, they have the same voltage. That means the voltage here is equal to the voltage here is equal to the total voltage here. Very important you know this, that the voltage in this region, everything here is equal to 24 volts. Everything here is 24 volts, just as 24 volts is what we have in the circuit. So if you have that knowledge, it means that 20 microfarad, the voltage here is 24. But these two capacitors are also sharing 24 voltage. So I will now have to know which one is going to be for 5 and which will be for 15. That's just the analysis. So now the question is to get which will be for 5 and which will be for 15 in this total of 24 they have. I will now first determine the total capacitance because I have 5 and 15 and they are in series. So I will determine what is the total capacitance because I know their total voltage already. So I will get their total capacitance. Then when I get their total capacitance, I can get their total charge. Then I can get the voltage in each of them. Now let's see that now. So I can say 5 microfarad and 15 microfarad are in series. Therefore, total voltage in series is gotten by 1 over C total is equals 1 over C1 plus 1 over C2. A short way to solve it, we said C total is equals product over sum. That's what we said. So it will now be equal to, what's our product? Product of 5 times 15 over 5 plus 15. So C total is equals 75 over 20. So this will now be equal to 3.75 microfarad. So you see now the total capacitance here is 3.75. So my C total is 3.75 microfarad. My total voltage is 24. V total is 24. So for these two capacitors, their total capacitance is that, and their total voltage is also 24. Now, let us now see what is their total charge. Total charge for 5 microfarad and 15 microfarad. V total is equal to, you know that Q is equal to CV. Therefore, what is now our V total? V total is now equal to charge total over voltage total. We're looking for Q. We're looking for the charge, sorry. So total charge is equal to total capacitance times total voltage. So our total charge is equals, total capacitance is this, 3.75 times total voltage is 24. So that will now be 90 coulombs. So now they have a total capacitance of this, total voltage of this, then their total charge is now 90 coulombs. So now, let's now see. Now remember that their total charge is 90 coulombs and the same charge that is here is the same charge that is here. So they have the same charge but different voltage. So the charge, so 90, so therefore Q5 equals Q15 equals Q total equals 90 coulombs. This shows that they have the same charge. So that's why I said the charge in 5 is equal to the charge in 15 is equal to the total charge. And what is the total charge? 90 coulombs. So therefore, now for 5 microfarad. Now I want to check for what is the voltage in 5 microfarad. For 5 microfarad, Q equals CV. Therefore, V equals Q over C. Let's see now. So V5 is equals, what's our Q? Our Q for 5 is 90. 90 over, what's the capacitance? Is 5 microfarad over 5. The answer is 18 volts. What about for 15? Let's see, it's still Q over C, which is now the charge for 15 is still equal to 90. So it's 90 over, what's the capacitance? Is 15. So this will now be equal to 6 volts. So you see that 18 plus 6 equals 24. So you see that 5 has 18 volts, 15 has 6 volts. Total will give us 24 volts. So when they are in series, they have the same charge but different voltage. But the total voltage is equal to the total voltage in the circuit. So if you were asked, what is the voltage in 20 microfarad? No need to solve. The voltage is equal to 24. 24 here, 24 here, 24 here. But when they now ask us to find for either of these two, that's what we just did all through this calculation to get 18 and 6 volts. Thank you. Now let's look at energy stored in a capacitor. Now the energy stored in a capacitor can be explained in a graph where we have charge against voltage or charge against potential difference. Now this is the curve of the graph. Then the area under the graph is what we have here. So the energy stored is equal to the area under the graph. And what is the area under the graph? It looks like a triangle. It's a triangle. So we said the energy stored equals area of a triangle. So if you come here, remember area of a triangle is half base times height. Therefore, it will now be half QV. Now recall that Q equals CV. Therefore, E equals 1 over 2. In place of Q, I have CV dot V. So E is now equals 1 over 2 CV squared. So this or this can be used to calculate for the energy stored in a capacitor. Thank you. Now we have a question, a circuit diagram, but the ratio of energy stored in P to Q is dash. Now let's see how we can solve such a question. Solution. Now remember, these two circuits are in parallel. Hence, the voltage here is the voltage here is the voltage here. This could be an exam question and this will just throw you off balance, not knowing that the voltage here is the voltage here is the voltage here. So what is the next thing? So remember, energy is equal to 1 over 2 QV or 1 over 2 CV squared. So which of them are we using to solve? This has capacitance and voltage. So we cannot use this. Rather, we are using this. Why? Because the factors available suits that formula. So I have EP is equals 1 over 2 CV squared. I have EQ equals 1 over 2 CV squared. What about this? This will not be that for P, while this will be that for Q, but these two are common. The V total is what I have here and is what I also have here. Take note of this. So now, why will I put V total here? Because the 24 volts, which is the total voltage, is what this 4 microfarad has and is what the 2 microfarad has. So now let's see what is now EP. EP equals 1 over 2 times. What is my capacitance? My capacitance is 2, then I would have said 2 microfarad, no problem, times, what about this? This is now 24, all in brackets squared. Now this cancels out this, then I'm left with 24 squared. What about my EQ? My EQ is 1 over 2 times, what is this? This is now 4 microfarad times another 24 squared. So I have this, cancel out this, that's now 2 microfarad times 24 squared. So now what is now my question? My question said the ratio of P to Q. So I'm looking for EP ratio EQ, which is equals EP over EQ. Take note of that, that's what it means. So now I have EP over EQ is equal to, what's my EP? My EP, remember I have here 1 microfarad times 24 times 24, that's 24 square, over, what about here? I have 2 microfarad times another 24 times 24 square. That's 24 square is 24 times 24. So this cancels out this cancels out this. Microfarad cancels out microfarad. So I can say that EP over EQ is equal to 1 over 2. So I will say EP ratio EQ is equals 1 ratio 2. So the right answer is A. Thank you.